Hey everybody, I'm going to be hiding behind the camera for this one. So this video is very important because it's about how to convert from math to NumPy. And I've already shown you some ways to do that. This isn't completely brand new, but I'm gonna be very clear about the ways that I am going to choose to represent stuff in NumPy most of the time. And there might be some rare exceptions when we move stuff around, but for the most part, we're going to treat column vectors. Say if I was to write A is equal to the vector of 1, then 2, then 3, well, I would convert that into NumPy like this. I would say A is equal to the vector, so that's going to be a NumPy.array, just like pretty much everything else. And I could choose to do it like this, which is kind of a vector. Sorry, I didn't import NumPy yet. You could choose to do it like this, but that's not really what a vector is. It's more so 3 rows by 1 column rather than just 3 elements. I know it's kind of a weird thing there, but most of the time, just to be really clear, and it'll help NumPy out as well, is if you write column vectors like this, because this is really what they are. If you think about the geometry here, it looks how it is. So if I have A here and it outputs like that, well then that's how you know really it's a column vector. Okay, so we're going to do vectors like this. We're going to do matrices. So if I had M is equal to, say, 1, 2, 3, 4, okay, then I could do this. So I could say M is equal to, I could do this in a couple different ways. We saw the arange function earlier, but I'm just going to do it explicitly as numpy.array of the list of 1, 2. So that's the first row is 1, 2. Then another one is 3 and then 4, just like that. And so M looks just like that. So that's how we'll represent matrices. And all the different operations, some of which we've seen, a lot of which we haven't, a lot of stuff that, you think you might want to do, you can do very easily. Again, we've covered a little bit of this already, but it's a really good refresher, is, maybe we might want to add a number to each of the elements. So maybe for A, if we had A here, well then A plus 1, so that in math is defined A is equal to, or A plus 1 is equal to 1, 2, 3 plus 1, which pretty much converts to, whether this is well defined in math or not, it pretty much is vector plus a scalar. Obviously you'd want to be doing this, okay? So you'd want to get that result, and that is perfectly valid in NumPy as well, so that works. Something else you might want to do, again, just to move this across, if you had A again is equal to 1, 2, 3, maybe you would want to add something specific, and so this is done in linear algebra a lot, is just adding a certain vector. So then if you had another vector B equal to, say, 4, 5, 6, and we'll make this over here. We'll get B is equal to the column vector, numpy.array. By the way, the easiest way to actually convert it to a column vector very easily is to write it like this, and then just use the reshape function, so that we actually we want specifically 1 column, and so we want 3 rows by 1 column, okay? And then so B looks the same, but we don't have to write it in that kind of irritating format, but it's the exact same thing. So then A plus B is well defined, and so we could do it like that. And again, just to be very clear, A plus B is equal to the element-wise addition, so 1, 2, 3 plus 4 plus 5 plus 6, which, as it says, is equal to the array or the column vector of 5, then 7, then 9. Okay, so that's well defined. We also might want to multiply by some number. Okay, so if we had A, again, I'm going to keep sticking with this. If we had A is equal to 1, then 2, then 3, well, we could do A times 5. Okay, A times 5, which, again, whether this is defined well in mathematics or not, it is, by the way, it is. So A is going to be, sorry, we have 1, it's basically 1 times 5, and this is 2 times 5, and this is 3 times 5. So this is equal to 5, then 10, then 15. Okay, there might be times when we want to multiply everything there, and we could actually do this with matrices as well. So sorry, I didn't do that in NumPy, but you know for sure. It's just as simple as a times 5, and so it's totally okay with that. We could also do, if we had the matrix, again, the matrix of m is equal to 1, 2, 3, 4, and then we could do m times 5. All right, we'll do a different number just for fun. M times 4, which is basically multiplying everything by 4. And so that would be 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16. Okay, again, we have M here as that matrix, and we could do M times 4. That's totally fine. And very similarly, you could also do M, so again, M is this thing, and you could do M divided by 2, for example. And so that's going to convert it to actually floating point values or decimal values, but that's what m over 2 is the exact same thing, but with division. All right, so all this stuff that, you figure you might at some point want to do probably makes sense. There's also more complicated things like this, rather than just adding. By the way, subtraction is exactly the same. You could do a minus b, or a matrix minus a value. You could also do, there's a lot of mixing between matrices and vectors, or just vectors and vectors. But for example, you could have A is this, and then say B, I think I have B, so we could do A times B. Okay, so notice I'm saying times and not the dot product. We could do A times B, which is equal to, well, A is 1, 2, 3. I'll just write it as, so this is 1, 2, 3, and that would be times, times, times. We're going to multiply that where B is 4, 5, 6. So this is 4, 5, and then 6. And so that is going to be still a vector, and then 4, 10, and 18. That's not a great 18. 18. Okay, so that's totally valid as well. To do element-wise multiplication, we might want to do that. We might want to do the dot product, which is very simply done with dot. Okay, dot actually does a lot of things, but if we had, remember, a dot b is totally valid as well, where basically that does the exact same thing here. It multiplies them element-wise, but then it actually sums them. So really, a dot b is equal to 1 and then 4 plus 2 and 5 plus 3 and 6, which we saw above is 4, then 10, then 18, and that sums to 14 plus 18 is 32. Okay, and we could do numpy dot dot a and b. So these are not aligned. So why is this true? The reason for that is because you can't, it sort of works in mathematics, and I'm being a little bit sloppy with notation sometimes. We're doing a dot product with a column vector and a column vector, which it doesn't like, and that's kind of annoying. To do this properly, you would actually need to do what we call the transpose, and so I'll introduce this now as well. You can just do, if this is A, then A dot T is the transpose, and so that makes it what's kind of like, again, this is really what a row vector is it's 3 elements in a row, except it's like a matrix because the shape of this thing is 1 row by 3 columns. So kind of weird, and don't worry about it too much. But what we'd actually have to do is instead np dot dot A dot transpose with B. And so that's okay, and it actually gives the list of 32. There's other ways too of it not given that with the list as well. If, for example, we could just had, and that's why I was being kind of sloppy earlier, is because it's weird with these different, NumPy is a little bit weird sometimes. And so if we had instead, I'll just do A1 is equal to the NumPy.array of 1, 2, 3. Okay, so just that normal thing. And then we had B1 is equal to just this normal thing as well, just the list past 4, 5, 6. Okay, so we could also do this as well. So numpy dot dot works with that. So that gives just 32. And that's why I was saying, like, is this a vector? I mean, kind of yes, kind of not. It's a little bit weird. And that's why to do it formally, generally you write these things as column vectors, except then it also gets a little bit irritating with NumPy, and you get a little bit of errors with the dimensions sometimes, and that's totally okay. All right, so we're just kind of fighting around with it. That's fine. So we can do the dot product. We can also do vector matrix multiplication, which we saw. So a big point of this video is to show you that there's multiple ways of doing these things, and depending on what you do, you think it makes sense, and then in NumPy you actually get an error. And I'll just show you, my way of fighting through these things and doing it a particular way so that we minimize these errors as much as possible. But I will see you in the next one.